All right, let's try this guy. So number 14 out of 18.2. So I want to calculate the line integral. So we want to do the integral over curve C of f dotted with dr. And our f is minus y sine x comma cosine x.
Yeah.
And our curve is a chunk of the parabola, y is x squared between 0, 0 and 2, 4.
Oh, then.
Okay, so first things first, what do you need?
Well, we're gonna need a parameterization.
Parameterization. Okay, so R of t is going to be what?
T squared.
T and t squared. Because if x is t, then y, right? The y component is whatever the x component is squared, so t squared. And where do my t's run?
From 0 to 1. It's one time frame.
0 is less than t is less than
1.
4, 1. Neither of those are right.
No, wait,
2?
It's 0 to 2.
So really, I'm looking for when does t comma t squared turn into 2, 4, right?
Oh, so 2.
So that seems like t is 2.
I was looking at y instead of x's.
Okay.
Okay, so I should be rewriting my integral over the curve of f dotted with dr as the integral from 0 to 2 of what?
Negative t squared sine t.
Negative t squared sine t.
Comma
Good.
cosine t.
Comma cosine t.
Dotted
With
1, 2t.
1 comma 2t dt. Okay, so we'll get the integral from 0 to 2 of
Negative t squared sine t.
negative t squared sine t
Plus 2t cosine t.
plus 2t cosine t
dt.
dt. Oh, which looks like horrible nastiness. Okay.
Parts.
Let's do some integration by parts. Okay, so this is going to be the, maybe I note over at the
Split
side.
them in 2 parts. And
Yeah.
then do by parts again.
Okay, let's split it into 2 pieces. So I've got the integral from negative, the integral from 0 to 2 of t squared sine t,
Yeah.
plus twice the integral from 0 to 2 of t cosine t dt, right? Okay, so let me move over here and just do antiderivative of t cosine t. You guys remember how parts works?
You can take out a t, actually.
UV prime equals
Yeah, you can do a u substitution of t, right? Oh, wait. No, never mind. No.
I forgot a dt. Why is what Donald's suggesting crazy?
Does it just replace one variable?
Yeah.
Yeah, sure. You can always swap the dummy variable in the integral, right?
It doesn't matter.
Its name doesn't matter. You can call it Steve if you want. It's still going to be integration by parts on this one.
Yeah.
Right, so I would not recommend doing Steve substitution on this.
Yeah.
I would recommend picking a u and a, wait, how does u
No, I was just saying
U
u
and v
prime
prime.
equals UV minus the integral of U prime V.
Okay, so
Make the t your u and your v prime cosine t.
Yeah.
okay, that's a good idea. Why would I do it that way?
That way,
Because
when
things
you
get
will go
easier.
away. Yeah, t will go away.
Good, things will get easier, right? The t will go away. So u prime is 1 really dt.
Yeah.
Really, I should write this as du. And
And
So-
cosine integrates to sine.
cosine integrates to sine. Okay, so then this integral of t cos t becomes
T sine t
sine t.
minus the integral.
Cosine.
Yeah.
so uv minus the integral of
Cosine t dt.
that.
Oh, wait, no.
That's not right.
Wait, sine t.
Okay.
Good job.
Which becomes, in turn, t sine t minus
Plus cosine.
plus cosine t.
Yeah, all multiplied by 2.
Okay, so then I should jam that back in here. So at my next stage, I don't know what this thing's gonna be yet, but I've got plus 2 t sine t plus cos t evaluated from 0 to 2.
Okay.
Cool?
Yeah.
Alright, see if we can lay our hands on the other one. So next thing's next. So probably go left some of that. I want to do the integral of what?
T squared sine t.
T squared sine t dt. Okay, so this is, I need a u and a dv.
I'm totally not sure.
Thoughts? Oh, come on, do the same thing.
We're gonna have to go 2 steps.
We're gonna have to do it twice, but we're
Yeah.
gonna do the same thing. So we're gonna let u be t squared, so that du is simpler, 2t dt. What are we gonna let dv be?
Sine t.
Yeah, you don't really get a choice in this, right?
Yeah.
It's kind of the rest of it. Sine t dt, so what's v?
Negative cosine. Negative cosine.
Negative cosine t. Okay, so I can replace my integral of t squared sine t with
T squared. Negative t squared cosine t.
negative t squared cosine t minus the integral of,
We should have done this part first.
I know.
Well, because it cancels out the other one.
oh, does it? Oh, stupid. Alright, wow. So, I got b du, right? So I got 2t dt cosine t with a plus. Yes?
Yeah.
Okay. And then I could notice, oh,
It canceled out.
it doesn't cancel it.
No,
adds
it
to.
adds.
Did you?
So, did I flip a side by
yeah,
accident?
it adds. Okay.
Yeah.
Okay, so there's gonna be another one of these, right?
Yeah.
Oh, no, I'm good. Never mind. Hang
What?
on, go back.
What?
Remember that there's a minus sign on it to start with.
Oh, okay.
Oh, yeah.
So what I'm gonna end up with here is that minus t squared cos t, but I need the minus sign on the front. So I've got
It does
minus
cancel.
all of minus t squared cos t plus the integral from 0 to 2 of 2t cos t dt plus that stuff.
Okay. So it's, yeah.
So I get t squared cosine t evaluated from 0 to 2. My bad. Minus all that jazz plus that jazz is plus 0.
Wait, actually, yeah. Really?
Yes.
Okay, keep going though.
Trust me.
Yes. I'm not, because like the first step is fine, like because you're all in there.
So
Oh, wait. Never mind. Yeah. I
this
got it. I caught
thing
up.
here,
Caught up.
right, is that thing there.
Yeah, I got it. Okay.
So if I hadn't done that, I
Yeah.
would have been better off. But I warmed up my integration by parts for the harder one, right? So what do I get when I evaluate this thing? It looks like I get
Yeah.
4 cosine of 2.
Which is positive.
Yeah.
That's it?
Mm-hmm. Well, you don't want to figure out what cosine
What?
2 is.
Why not? What's the rest? Where'd the rest go?
Well, t is 0
Minus
zero
0
multiplied by cosine 0.
What, do you want to add a constant plus c?
Alright, perfect. So we got 4 cosine of 2. Cool? Plus doesn't count.
I I know, but it's like, it's really close. So what did I do wrong? Question.
So